Ladies and gentlemen, our next session is a guest par note on the topic AI is eating software. Our speaker for this session is Rajat Monga, co-creator and former head TensorFlow. As a founding member of the Google Brain team, Rajat was involved in designing and implementing Disbelief and more recently TensorFlow. Prior to this role, he led teams in AdWords, built out the engineering teams, and designed web-scale crawling and content matching infrastructure at Attributor, and co-implemented and scaled eBay's search engine. Pleasure to have you here with us, Rajat. Over to you.
Hello, everyone. I'm Rajat Monga, and I'm here to talk about how AI is really changing the world of software. So let's first look at what's AI and what are we talking about here. So one of the core components of AI as we see it today is deep learning or deep neural networks, as you might have seen it. Here's an example of a deep neural network. The way they work is you have an input, in this case, an image, where we're trying to understand whether it's a cat or a dog. It goes through this set of functions. Each layer is sort of a set of functions that's being applied to that, and they are stacked on top of each other. That's why they're called deep. Finally, going through all of these functions, eventually the top layer, the output layer, really makes a prediction on, okay, in this case, is this a cat or a dog? If the prediction is right, great. If it's wrong, then it's actually learns from that incorrect behavior, from the error, how it's doing, and over time updates its weights or parameters of these networks to really learn what's going on. And this is really wide implications. It's being used across the board. But now let's take a look at what's really gotten us together over the last decade. What's really changed that's really helped it succeed so much? The first thing, of course, is algorithms here, which we talked about, deep neural networks. Next, what we see here's an example of a data set, in this case, Imagenet, which has over 1 million images across 1,000 different categories. And it's been used very widely to really learn and train on them. That's number two, really. Data that has come together that's helped us build these neural networks and improve AI to a point where it's really, really useful. Of course, sometimes this can go to an extreme. You've probably seen lots of things across the web trying to answer things and say if things are wrong or right. Hopefully, we're not using them for self-driving cars while they're waiting on a stop sign for you. But this is just an example. Everywhere, people are trying to collect data, use it in lots of different ways. Now, the last thing that really helps these two come together, the algorithms and the data, is compute. These algorithms, turns out, they need lots and lots of compute. And so over the last few years, we've seen a bunch of custom hardware being built just for this. In this case, these are tensor processing units or TPUs built at Google. This one's a TPU pod with over 100 petaflops. In fact, the newest one goes way beyond this. I think it's about an exaflop itself. And to give you a sense of what this compute power is, it's really equivalent to one of the fastest supercomputers in the world. It could be one of the top 10 supercomputers, but also it's equivalent to over 100,000 laptops that you typically use every single day. Now, all of these three have come together, over the years, where we have data, compute, and algorithms, and really put together enabled by software such as TensorFlow, that really allows us to leverage the power of these together, that allows us to build these algorithms, to define new algorithms, to do research on those, and to be able to leverage specific compute like the TPUs and to take advantage of that in amazing ways. Now, of course, let's go back in time over the last decade and see how this has changed things. So one of the earliest areas that this applied was images. And in this particular example, back in 2011, 2012, there was research at Google that was basically training networks across thousands of machines. These were CPU machines back then, leveraging the YouTube videos, back then, and perhaps even now, a lot of YouTube videos of cats. People love cats, and so there are lots and lots of cats in there. And in this case, the algorithm, turns out, was not really told what to learn from. It wasn't told what's in there. But just from seeing so many different videos of cats, it learned to recognize cats automatically. There were neurons in there that would understand, oh, it's a cat, it would fire, and so on. And here's an example of a cat that it would fire very well on. Around the same time, there was lots of other research going on as well on the Imagenet dataset. So there was a competition in this one back in 2012. We saw results leveraging just 2 GPUs and leveraging the power of what were called convolutional networks on the same data set, there was a huge jump, going from about 50-55% to about over 75% in accuracy. So at least 3 out of 4 images were the right classification in this case, which allowed things to move from, oh, let's write lots of custom software and different kinds of features, to, oh, can we just train models to train these? This was way better than anything before this. Over the next couple of years, there was lots more improvements. This example is for GoogleNet, which was again trained on hundreds of CPUs, same data set, improved the accuracy even further. And as things kept getting better, what that really changed is how software was built, how things were being done. So Google Photos, probably many of you are familiar with it. I'm sure lots of you use it as well on your phones, etc., to automatically label your pictures. Now, this wasn't always the case. In fact, less than 10 years ago, there were lots of software being built to really help you label your own pictures. One example that comes to mind is Picasa, which Google bought at some point and eventually morphed into Google Photos, or got revamped or replaced by Google Photos in some sense. And how this has changed things is going from, oh, people need to label, to it's automatically labeled, just changes how you need to build software. You need to think of things very, very differently. Now, here, of course, because it's labeling, you can search for things like pictures of dogs or pictures of a beach or your vacation on a beach and so on. Now, instead of typing it, what if you could just say out loud, oh, I want to see pictures of cats? And that's exactly what deep learning has allowed us to do, with the same kind of algorithms being applied to speech data sets. In this particular case, there was a data set of over 1 billion examples running across lots of CPU machines that allows us to make huge improvements on speech itself. In this particular case, when this was announced, this was over a 20% improvement. And in the words of researchers in that field, this was equivalent to 20 years of research with one change in the algorithm. And that was just huge. Now, from that point, of course, that was just the starting. There have been lots of incremental improvements in speech as well. From there, we went to LSTMs, which added another 10%. Over time, it's gone to transformers and other algorithms, which themselves have added 5, 10%, and so on, to a point where it's over 90% accurate for lots and lots of cases. In some cases, even way more. And in lots of cases, it's as good as human recognition as well. Now, what that's allowed us to do, of course, is have objects around us like Alexa or Google Assistant, OK Google, Siri, etc., where instead of always typing or using some other way to enter text, we can say out loud, we can try and talk to our computers as well. Now, when you think about how do we communicate, images is one way. We want to understand and see things. We hear things. But the last bit here is for communication is understanding the natural language itself. So far with software, it was always about, oh, we need to give it exact commands on here, what things to do. Now with natural language understanding, we can really help it in some sense, say things out loud in natural language and expect it to do more of that. Over the last few years, we've seen huge improvements in there. Not done yet, but we've seen huge improvements where we're seeing actual applications and scenarios. So just a few years ago, there was a new algorithm called transformers, part of the deep learning family, so to speak, that allowed it to beat humans on this particular data set called SQuAD or Stanford question answering data set, where the idea was, okay, here are a bunch of questions. Here's like a reading comprehension passage. Here's a passage. You need to answer all these questions. Turns out it can do better than humans on that. Now, the exciting thing, of course, is if you're trying to do a test, don't you wish that it would do better, really answer the test for you? Not quite. You'll still have to study for your tests. But in lots of areas, we can really apply that as well. Now, what this has changed, something that you probably use often, Google search is the most widely used search today. Here's an example of how it was before this change, before this was incorporated and after this. So as you can see, it's a more complex query where we're trying to look for somebody who goes from Brazil to US and whether they need a visa, what kind of thing. Before, it just took all those words together and just matched them. In this case, it's trying to find what US citizens need to travel to Brazil, probably because the search was being done in US. After this, it actually understands what the sentence is about and really matches it to the right thing. And that is really changing what our expectations are, what we can get out of that as well. Now, this is one example of how it's being applied into real software and how it's changing. Let's take a look at a few more examples in different areas. Here's one directly on your phones. We've all come to expect phones to have a good camera. In this case, I have a Pixel. This is a slightly older version of Pixel, but in many cases, phones today have 2, 3, even 4 cameras or more. And what they do is combine those cameras using software to really understand what's foreground, what's background. In this case, it's trying to blur the background. In this example, in fact, doesn't even necessarily need multiple cameras. Sometimes can use just one camera with some tricks to understand what's the foreground, where the person is, where the boundaries are, use that to blur the background. And it does that, all of that running on the phone. Just changes how things are done, changes what's enabled with this. Now, it's not just about blurring. In fact, here's an example where we take pictures all the time with our phones. Not all those pictures are good. Some pictures are blurry, like the ones in the top. Some might have, say, rain falling in there as well. And now we have software that really leverages deep learning again to clean them up, to make them way better than how we've taken them. There are lots of techniques that are continuously improving. And so changing how software is built, changing what kind of things we can do with it. Again, going to an example on the phone itself, where this is something for people who can't hear so well, or perhaps you're trying to listen in a noisy place, where instead of having to listen to things on the phone, it can live right there show you captions of whatever audio is coming through as well. That just is not just, of course, it's helpful if it's not noisy or loud and stuff and you can't really hear, but also really, really helpful for people who have trouble hearing and understanding things there. So here we talked about some standard applications. And so let's take a look at a little beyond on what's happening, with other areas, somewhat research, but really pushing the boundaries of what's possible. This is an example of AlphaZero, which has been applied to multiple games. It combines deep learning with reinforcement learning and a number of other techniques to really change how things are done. So here it shows for chess, shows it playing against Stockfish. Stockfish was a software that was being used for a long time. It's used by the top GMs in the world to really learn, and even players, a lot of top high-end software for chess includes that or uses that really under the covers. Now, in this case, this model just learned by itself with a lot of training to do much better than that. And not just on chess, on another game called Shogi, and also on Go, which was the hardest game for computers to beat for a very, very long time. Now, of course, these are games, but this is applications or implications for a lot of other things as well. Let's take a look at one example. So this example is for AlphaFold. And this is something that is, if you're familiar with proteins and protein folding. So this is a real world application where scientists for a long time want to understand, they have this large molecule of protein. They want to understand how it really exists, what's the 3D shape, etc. Because understanding that gives them a much better sense of how it will interact with other proteins and what it would work, what would not work, and so on. This has been a hard problem for decades. With AlphaFold applying similar technology to what we saw in those games, it has allowed it to do really, really well, over 90% accurate on these problems for a large data set that we have. Of course, not everything's perfect with AI. Let's take a look at a couple of issues that we are seeing as well. We want to be mindful of those as we leverage AI in everything that we do today. First, here's an example of a camera, a public camera in the city. It's there in many cities around the world today. And what it can do is real time, automatically figure out where the faces are. If you have a face recognition data set to go over there, it can match those faces there as well. And of course, the implications of that are They can be used in good ways, it can be used in bad ways. So it's really tricky. It can be used by dictatorial regimes to really track people that they don't care about. On the good side, you could say police could use it to track criminals and find them, but they are both, there's a very thin line once you have that power. You have to be very, very careful how that's going to be used. Here's another example.
These things, at least not in a public address, but someone else would. Someone like Jordan Peele. This is a dangerous time. Moving forward, we need to be more vigilant with what we trust from the internet. That's a time when we need to rely.
So here's an example of where you saw it seemed like Barack Obama, the former president of the United States, was speaking that, but in reality, it was just his picture. And the speech was from the person that you saw in there. This is just an example to illustrate the kind of problems we can face. Today, it's actually being used in some places, mostly for good that we know, but also some for bad. And we want to be very mindful of how this gets used and how we prevent the real problems that can arise because of this as well. Of course, this is some of the issues. There are some other issues that perhaps AI can help with as well. So let's take a look at one particular challenge for humanity that we're seeing that is both problematic, but perhaps there's a glimmer of hope as well. So if you look at energy, think of the energy used to boil one pan of water. That one pan of water, now imagine that every single person in the world, about 8 billion people, are boiling that one pan every single minute, round the clock. That's really how much energy we're using every single day. And most of that today is still being generated from fossil fuels, like oil in this case. Of course, we know of climate change, lots and lots of issues. There are drought in some places, floods in some places. And this is just the beginning. This is there are lots and lots of issues here. Of course, the good thing is there are things that are being done to improve on it. For example, clean energy. There's a lot of work happening, and AI, in fact, is also helping in many ways. In these examples, for detecting problems with wind turbines, automatic drones that look at these blades that identify their problems and stuff, forecasting solar efficiency and winds, because that allows for much better utilization of this renewable energy. So at the end of the day, there are lots of things that we have to think about, lots of improvements that have happened with AI. And overall, AI is really making a big difference. Thank you.
Thank you, Rajat, for that presentation.